This video covers the concepts of code coverage with respect to unit testing in Java programs. Detecting bugs earlier in the design cycle is highly desirable because it improves software quality and reduces impacts on costs of software development. So many different testing approaches are used. For example, unit testing is to use test methods and classes as they are developed. Functional testing tests functionality or features can typically involve multiple classes. Regression testing aims to detect if existing features were broken. That means you already had a set of features, and as you add functionality, you don't want to break existing features. And integration testing tests interoperability between software systems that we are coupling to build a larger system. And performance testing tests the speed and response times of software and tests scalability of systems as well. In this presentation, we are specifically going to look at code coverage from the perspective of unit tests. Unit tests essentially look for errors in isolated subsystems or specifically classes and methods. And it's a very common type of testing, and all programmers are expected to be able to be comfortable and, in fact, proficient at unit testing. And generally, here, a subsystem in this context is a specific class that we are testing, or possibly it could even a set of methods that we are testing. The key question then becomes, if we have to be good at unit testing, how can we tell if we are doing a good enough job at unit testing? That means, how can you tell we are doing appropriate unit testing? And a common metric that is used that is based on the fraction of code that is executed. That means we have a class under test, and we want to figure out what fraction that we are executing or we are exercising to figure out how good our test cases are. And this metric, that means the fraction of code covered, is called code coverage. Code coverage is a measure of the degree to which some part of the source code is executed by a particular set of tests. And typically it's represented as a percentage, and in practice, at least an 80% coverage is recommended. So for small classes, we should be able to pull off 100%. But for larger, more complex classes, an 80% coverage is highly recommended. This metric is also useful for unit tests, and Eclipse IDE provides a very convenient tool to report code coverage. So for example, when you're running a unit test, you can simply use the menu option, right click on the test and run it as coverage as a unit test, and it will start generating coverage metrics for the different classes that we are testing, and you can see how much of the code is covered and what lines of the code is covered, so on and so forth. And of course, this report is generated after the tests are run, and it's generated for the whole project. So if you're testing only one class, then obviously other classes may not be covered, but hopefully as a collection, your test suite will cover all of those different classes in the project. So the way the lines are color coded, you will see green lines. That means these green lines are actually fully tested. Sometimes you will see yellow lines. That means these are partially tested. That means there is some more additional test cases are required in order to fully test the functionality of those lines. And red lines are essentially untested code. That means we do not have any test cases that exercise that part of the program. Let's see how we can do code coverage and run the code coverage analysis in Eclipse. For this demonstration, I already have a Eclipse project that is set up, and we're going to use a car class which basically has a make and a mileage, and then the constructor of car basically sets up the mileage, and there are different methods. Notice that there is a get make method, there's a get mileage method, there's a drive, horn, toString equals, pretty standard set of methods in the car class. I've already started up a simple demonstration unit test where it's going to test the equals dot equals method, and it's also I have a test. Notice the at test annotation to test the toString method. Typically, we will run this application as a JUnit, so that means you would go do the car test and run it as a JUnit. But instead, for code coverage, notice that there's a coverage as menu, so click in coverage as and run it as a unit test. Here, Eclipse will run the unit test and as a unit test, so you can see the results from the unit test. So here there were 2 tests run, and you can see the results. Both of them were successful. And then you can see the coverage metric. So notice that in this demo, between the car class, the car test obviously is 100% because all of these lines of code were executed as part of the test. So you see everything is green color. So you got a 100% test there. But in car.java, when you switch there, you will see that, of course, the toString method is executed, that line. And then you'll see in the dot equals method, not all of the options were executed. That means only one of four branches were missed. One of the four branches. That means notice that in the testing, we have tested object equals, we've tested for null, but we have not necessarily tested for something that's not an instance of car. So that line is not highlighted. And also with the mileage checks, we have objects that have the same mileage. Notice that we have objects with the same mileage. So it's basically telling us, we didn't quite exercise this mileage check in the equals method. So that means the equals method. So let's see what's the coverage on the equals method. So equals method, it says almost 100% coverage, so we're doing pretty okay there. ToString is 100%. But notice that the drive method and etc. We're not really tested. You see how the drive method, mileage method is not tested. So that means overall in the car class, we don't quite have an 80% coverage. We have only a 57% coverage. So let's try and go fix this issue by adding a new test. So what I'm going to do is I'm going to clear out all of these markings so there's no confusion. And then I'm going to close out the older tests. So let's add a new test that's going to test, let's say, the drive method in the car class. Yeah. Notice that by default this is a method, but if you want to make it a unit test, you add the test annotation to it. Let's do the same thing. Let's create a car here that's called Honda. But instead of creating a default Honda car, I'm just going to use a constructor that takes just one argument, because now my test case will cover that constructor as well. And then I'm going to make sure that I'm starting with the correct mileage to begin with. The mileage should be 0 because that's the initial default assumption that I'm making. Then I'm going to drive the car in forward for say 50 miles. Then I'm going to say my expected mileage on this after driving for 50 miles is going to 50. Then I'm going to drive the car, let's say, in reverse. So that means I'm going to give it negative 50 because I'm thinking about all of the different cases that can happen. And now after driving for another 50 miles, my mileage should not be 0, but it should be 100 miles, because it doesn't matter whether I drive forwards or reverse. I expect the mileage to go up. Now let's try and rerun this. There are no compiler errors, so let's try and run it with coverage to see how we're doing now in our unit test coverage. And now let's go look at our car coverage. Okay. Now look at that. Now on a car Java, we are now almost up to a 81, just over a 80%. So we can see which method. The only method we haven't tested is the get make method. Otherwise, we're pretty good. And of course, there's a honk horn method. Those two methods are still untested. But overall, we're doing pretty good on most of the key metrics or key methods in this class. So we get a coverage of 80%, over 80% on this car class. Ideally, we should also do tests for the honk and get make, which we can always add. But here's just a demo to show how to get to that 81%. And you would do this for every class in that project. And this is how you would run code coverage in Eclipse by right-clicking, coverage as, and run your unit test to detect code coverage that is provided by your unit test. Keep in mind, it's practically impractical to test every possible input parameter value, so you should think about a limited set of tests that will expose most likely bugs and so on and so forth. So you want to maximize your bang for your buck for the test you're writing. Think about boundary cases, and here, of course, data types help a lot in testing. This is, in fact, having those data types is invaluable for testing. Data types are invaluable, so you know what if you're integers, you should test with positive, 0, or negative numbers to see if there are any edge cases or boundary cases. And these are issues right at the edge of, let's say, an array or collection sizes. Like sometimes less than equal to kind of issues can happen, like less than 0, less than or equal to 1. So check those boundary cases. Think about empty or error cases, so think about like 0, -1, or null for if the method takes an object, or empty list or arrays, things like that. So think for those edge cases or boundary cases when developing tests. And test behavior in combinations. Sometimes add, let's say you have a method like add, it might usually work, but for all you know, add could fail after you call remove. So sometimes doing this combination tests might be useful. And make multiple calls to methods. Maybe a method fails the first time we call it, but maybe the second or the third time it might fail. So think about all of those kinds of testing ideas And of course, this does require some experience so that you can build a good comprehensive unit test for the software that you're developing. Yes, you're also developing the software and also thinking about testing the software as you develop it. Yeah. And this code coverage metric is a great way to assess if you're doing a good enough testing on your software. Enjoy unit testing and doing the code coverage analysis. It's a very, very important skill to keep in mind. Good luck.